Hello, and welcome to another edition of the Daily Bolt with your host, Dr. Jeff Tilley. That's me. Today's topic, Profiles in Science, Benjamin Franklin, Part 2. Sit back and relax and enjoy today's Daily Bolt. So, we are picking up on the discussion that we started yesterday about Benjamin Franklin and his scientific accomplishments during the 18th century, during which he lived. And we talked a bit about some botany exchanges in terms of seeds that were sent back and forth, all of his accomplishments in electromagnetism, which are more extensive than most people are aware of, and even some work in terms of ocean observations determining the existence of the Gulf Stream, among other things. We're going to pick up from that point and look at some of the things that Franklin did in some other areas and other scientific fields. And let's get straight into it. So, we talked yesterday about how this period in time in history was known as the Age of Enlightenment. I don't know if I've spelled enlightenment correctly. It looks like on the slide it probably isn't. I apologize for that. But we're going to move on. And we're going to go back to biology for the first additional area of work that we're going to talk about today. In particular, we're going to talk about Franklin's work to try and increase the production of and cultivation of silkworms to produce silk in what he had hoped would be a highly profitable industry within the American colonies. Within the 18th century, especially the second half of the 18th century, silk became highly desirable for various things that it's used today, for clothing, for sheets, for bedding, probably for curtains, draperies, other accoutrements that the upper classes of society wanted to have. Silk is derived from the larvae of a particular moth, species Bombyx mori, and the thing about this particular species is that it has a diet of Asian white mulberry tree leaves that are slightly wilted. The slightly wilted is not necessarily the big thing involved here. The fact is that Asian white mulberry trees were not native to North America, and certainly the American colonies. But Franklin promoted the importing of some white mulberry trees and also any seeds for those trees to the American colonies. But the trees did not thrive. They didn't last very long, meaning that the silkworms also couldn't thrive because that's the only thing they eat. They wouldn't eat any other type of tree leaf. Very fussy species in that regard. And so this experiment in trying to get silk to be a produced commodity within the American colonies was a failure. But like most scientists, Franklin realized, okay, some things are going to work, some things are going to be successful, other things are just not going to work and be failures, let's move on. And he did move on to other fields, some of which we talked about yesterday, more of which we're going to talk about on the next slide. The first of these is volcanology. There was a period of time in the 18th century that there was just persistent clouds and fog over the British Isles and much of Western Europe. And through a series of systematic observations, Franklin was the first individual to postulate that this actually was related to massive volcanic eruptions that were occurring on Iceland through this period, and that those eruptions actually were documented, and the correspondence between the pattern change in the weather and the ash cloud being thrust up into the Earth's stratosphere, a second layer above the surface. We can talk more about that later, but the stratosphere is a layer that once you get volcanic ash up in that layer, it tends to persist for a very long period of time. Weeks at minimum, months is common, years can even occur as well. And so Franklin postulated that this volcanic eruption was putting so much ash into the atmosphere that it was causing a change in the weather. And this particular observation and postulation has actually been verified through more modern science in terms of observations and numerical models. ash cloud deposits into the stratosphere will tend to circle the globe with the prevailing wind patterns, and they will act in a cooling fashion that can act to actually modify regional and even global weather patterns for a period of time. This is a widely accepted theory, and it can be traced back to Franklin and his observations and his postulating that the eruption had the primary impact to create the bad weather. More meteorology that was involved in Franklin's work was that through, again, observations, he postulated the existence of what we call the nor'easter storm. Very powerful storm that goes along the Atlantic coast, usually tracks from southwest to northeast, relatively close to the coast, often along the Gulf Stream for a short period of time, and then up off the coast of New England, bringing very strong northeasterly winds onshore, usually causing a lot of rain, sometimes heavy, heavy snow. And up until this time, people had believed that the nor'easters, because the winds were coming from the northeast, well, that's where the storm must be coming from. But that's actually not the case. Because of the counterclockwise rotation around low pressure centers that we now know and take for granted, the storm has to track from the southwest to produce the northeast winds coming into the coast of New England and the mid-Atlantic states. And Franklin, again, was the first to postulate this based on the observations that he was making. So there's something else that he came up with that has been standing the test of time in terms of atmospheric and weather system theory. Finally, we're going to talk about astronomy. And Franklin, along with about 170 other scientists around the globe, observed the transits of Venus across the sun's disk in 1761 and 1769. Now, a transit is what happens when, in this particular case, Venus passes through the direct line of sight between the Earth and the Sun, and so we can see the disk of Venus. It would be a relatively small circular pattern, basically travel across the face of the Sun with the telescopes at the time. With the information that you can get from all the individuals around the globe observing this transit from the different angles, you can actually use rather sophisticated mathematics that were in place at the time to compute the distance between the Earth and the Sun, which we now know as one astronomical unit, 93 million miles and some change. And again, Franklin wasn't solely responsible for this particular discovery, but he did play an important role. And the most important role that he played in this particular discovery was that he allowed these observations and the computation of the distance of one astronomical unit to be published within the journals of the American Philosophical Society, which he founded for the presentation and publication of scientific results for scientists around the world to read, comment on, and learn from, and even debate. So Franklin still played a fairly valuable role in that. So this is a lot for one individual. If we take what I talked about yesterday plus what we're talking about today, Franklin was very active in the sciences. Yes, he was also a politician and one that we recognize through history, but his scientific accomplishments at least rivaled anything else that he ever did. In fact, in my mind, he may have been even more important as a scientist than he might have been as a politician. I'll let you figure out whether you agree with me with that or not. You can always send me comments and tell me that you think that his science accomplishments weren't as big a deal. We can have a nice discussion and go from there. But for tonight, that's going to be it for our discussion of Benjamin Franklin and this Daily Bolt. I'm Dr. Jeff Tilley. Have a good night, a good morning, good afternoon, depending when you're hearing this. And since it's a Friday, have a great weekend.